This question just brings in vectors a little bit, I suppose. So I haven't bothered with the context. We've got a ball being hit by a racket, I think, from a height of 2 meters above the ground, and this is already in component form. So direction, or the velocity, is 5I plus hj. And we want to find the greatest height reached by the ball. So that's your initial velocity. And so we want greatest height. We've got this going on vertically. And so we're looking at resolving vertically and take upwards to be positive. And so vertically, initially, u is equal to 8. And you can just pull that straight from here. The greatest height is where it's travelling horizontally, and so the vertical velocity will be 0 at the greatest height. A is equal to negative 9.8, and we're looking for S. So v squared, excuse me, equals u squared plus 2as for this one. And so 0 is equal to 64 minus 2 times 9.8 s. And so s is equal to 3.265. That's not the greatest height reached by the ball above the ground. Make that clear. So again, just check you're answering the question being asked. So the greatest height above the ground will be 3.265 plus 2. Which is 5.265 meters, but that's too accurate. So 5.3 meters as your answer to 2 sig fig. And then the next bit is find the speed of the ball as it reaches B. So B is where it lands. So speed of ball at B. So again, we're resolving vertically. And so this time, the displacement is minus 2. A is still equal to minus 9.8. We're looking for V, and we know that the vertical component at the beginning is equal to 8. So it's V squared equals u squared plus 2as again. So from there, you get V squared is equal to 103.2. You can square root that to get V. Remember, this is just the vertical component. And so when we're coming down here, like this, so V is plus or minus the square root of 103.2. So you're going to have a horizontal component and a vertical component. And to find the speed, you need to use Pythagoras. The horizontal component is constant, so this is always 5, and as a length, this is the square root of 103.2. It is acting in the negative direction, but speed is a scalar quantity, so it just has magnitude. And so the speed is equal to the square root of 103.2 plus 25, and that gives you the speed when it reaches B as being the square root of 128.2. Obviously that's too good an answer, and so to 2 sig fig, that's 11 meters per second. And then part C of this is the angle. So they ask you to find the angle the velocity the ball makes with the ground. And so the angle that we're looking for is sitting in here. Sorry, I'm just going to my notes. Making sure I'm the right way around. 100 and, yeah. So it's this angle in here that we're looking for, which is the same as this angle over here. And so tan theta is equal to the square root of 103.2 over 5. So tan theta opposite over adjacent. And from there, you get theta is equal to 64 degrees to 2 sig fig. Hope that's all right. Sorry, it feels slightly rushed today. But yeah, just bringing in those vectors just a little bit with that one there. And so to find the speed, you use Pythagoras on the right angle triangle. The horizontal component of the velocity remains at 5 throughout the motion of the projectile. I think the rest of it should feel okay, hopefully.